All righty. Thank you, everyone. Welcome to Datapalooza 2024. We are going, I only have, I'm Jeffrey Bloom. I'm the Associate Dean for Academics and Faculty Affairs here at School of Data Science. I only have a short 45-minute introduction. You could smile, it's okay. Mona knows me. Yes, okay. So welcome to Datapalooza. It's a privilege to welcome you all to our annual flagship event and to host it for the first time in our brand new beautiful building and the Capital One Hub. So Datapalooza was first held in 2015. It highlights the core values of the School of Data Science, where we try to foster collaboration and engagement in data science, research, and education. We recently welcomed our first class, the Bachelor of Science and Data Science majors this fall, and that completes the school's suite of data science degrees from undergraduate through PhD. So it's an especially exciting time. I'm also get to welcome, we have about 50 students from our online Masters in Data Science here in person. Yeah, so all right, so it's great to see everybody in person. That's fantastic. Okay. And of course, it's great to welcome everybody who's with us on the live stream. You just saw a picture of what you look like, but I don't think we have a picture of what they look like. This year's theme is inspiring the next generation of data science leaders, or data leaders. The theme reflects the school's commitment to teaching and practicing responsible data science for the common good, and our commitment to fostering good data citizens and thoughtful leaders in what I call the data arts. Datapalooza in 2024 promises an exciting afternoon of exploration, learning, and data science innovation, and here are just a few highlights. So you can find today's agenda by scanning, there's a QR code on the back of your name tag, or visiting the list of events on our website. Only events in the Capital One Hub are going to be live streamed. Breakout sessions will be held in the first floor corporate commons and second and third floor classrooms. If you need directions, please ask one of our student ambassadors or volunteers. You can get one of these cool Datapalooza t-shirts. It says hold it up. Here you go. All right, cool Datapalooza t-shirt. To get one though, you have to attend 3 sessions. This counts, the keynote conversation, 1 breakout session, and our industry panel. And there are students with stickers that will give you stickers. You can get your sticker. And then at the end of the day, you can pick up your t-shirt after the industry panel and right before our networking reception. Restrooms are located in the southeast and southwest corners of the building. In case of an emergency, follow signs to the nearest exit. I mean, this is required. If you're on the live stream and there's a fire, turn your computer off. Before introducing our first talk, I want to thank our industry partners, Capital One, LMI, and the Noble Reach Foundation. We're grateful to our partners, our guest speakers, our volunteers today, and of course, all of our staff, faculty, and students who contribute so much to making Datapalooza a success year after year. It's their commitment to helping us build this community that allows us to do lots and lots. It's my pleasure now to introduce Mona Sloane. Say hi, that's Mona, who will be moderating our first conversation with 2 impressive industry leaders on data, business, and the real world, insiders on how AI became a thing. Mona is an assistant professor here in the School of Data Science and in Media Studies, where she explores the intersection of technology and science with a focus on AI design, use, and policy. Mona serves as faculty lead in the Digital Technology and Democracy Lab. She is affiliated with the Department of Women, Gender, and Sexuality and collaborates on TYDE research initiatives. She also leads the Co-opting AI series and edits its accompanying book series. And her research group, the Sloane Lab, investigates AI as a social phenomena, emphasizing responsible AI and public scholarship, which is fantastic. And so we're very pleased to be able to have Mona here and for Mona to host and to kick us off for Datapalooza. So thank you very much, Mona.
I'm so happy that you made it out on a Friday, on this gorgeous Friday. I'm also extremely happy to see so many students, some of whom are or were mine. So great to have you here. It is also my distinct pleasure to welcome to the stage and the School of Data Science, Miriam Friedel and Don Wu, who are our terrific panelists today in a conversation about data, business, and the real world. We thought we would start with sort of a reality check, what data science really is out there. So Miriam is a vice president of machine learning engineering at Capital one of our partners here, where she leads a team of engineers building tools to solve machine learning and AI problems across the enterprise, which means she does a lot of things and has a lot of emails every day.
Yeah, true.
She's sitting at the intersection of statistical rigor and engineering at scale. And her team has helped bridge the gap between experimentation and production on some of Capital One's most critical problems. Prior to her role at Capital One, she was the head of data science at Scafos, an e-commerce startup, and director and senior scientist at Elder Research, where she served clients across a variety of industries. She has spent over 15 years in scientific and technical fields, spanning theoretical physics, software engineering, transportation, neuroscience, management consulting, and machine learning. Cakewalk. Her unique background enables her to lead with empathy. We don't talk about that a lot, but that's extremely important, as well as create cohesion and remove blockers and cross-functional, high-impact initiatives. Miriam received her Bachelor in Science in Physics from Brown and her PhD in Physics from the University of California, Santa Barbara. And she is the co-author on more than 15 peer-reviewed articles. Welcome, Miriam. Thank you so much for joining us today.
Thank you. If I had have known you were going to read that bio, I would have made it shorter.
No. We're making a point of this because we're going to come back to all of these things in this conversation. Welcome, Don Wu. It's such a pleasure. At this point, a big thanks to Lauren Goodwin, who introduced us, a mutual friend and your colleague. Don is a Wahoo and graduated from our very own McIntyre School of Commerce. And currently serves on the school's AI task force and the advisory board for the Center for Business Analytics. He has also helped co-create the field of applied data science. He currently serves as the senior vice president and the chief data and analytics officer at New York Life, in which role he's responsible for driving the strategy and the delivery of New York Life's AI data and insights capability in support of business strategy and objectives. He's also an AI and data advisor to Iconic, which is a venture and investment management firm based in Silicon Valley, so bi-coastal. Before he joined New York Life in 2023, he was chief data officer at Northwestern Mutual, where he helped drive the company's digital transformation and reset the company's data and AI strategy. He also co-led the Northwestern Mutual Data Science Institute, a partnership between Northwestern Mutual, Marquette, and the University of Wisconsin-Milwaukee. He has also held senior data leadership positions at Major League Baseball, BAMTech, which was acquired by Disney, and WeWork. Welcome, Don. All right. So lots of experience here. What I asked these two to bring to kick off a conversation is a little spiel, a little musing on how they got to where they are today vis-a-vis how the field of data science has developed, the field that now is a thing that we all work on. Miriam, how did you get here?
Oh man, it was not a straight line, as you can hear from my bio. There was a lot of meandering, which I think often happens in this field. But I'll talk, I don't know if I'm the best person to talk about the history of data science, because the history of data science is long and I'm relatively new to it. I would say I entered the field really in 2014 when I moved to Charlottesville. But I'll talk about some observations I've had and things I've learned throughout my career. So as you heard initially, like the first thing I did was get a PhD in physics. And the thing I like to tell people about that, which is actually surprisingly relevant to my role today, is I studied computational biophysics. So for those of you that are familiar with protein folding, right, you have to understand how proteins go from a sequence of amino acids to like their folded native state, right, because that's how they do whatever they have to do. So I studied this using computational and statistical physics. And what that meant is I had to take, scientific principles and put them on a computer and write code and make sure it was correct. So the code had to more or less, it couldn't take forever to run, but it was not well written, right? I wasn't using version control. Like it was kind of a mess. I have it on my laptop somewhere, and I'm like kind of afraid to go back and look at it. But the notion of, are you calculating what you think you're calculating, and are you rigorously testing that is actually sort of relevant to my role today. So I took those learnings, but I didn't really want to be a professor, right? I know some of you are professors, some of you might want to be professors. It just wasn't for me. So after grad school, I moved to Princeton, New Jersey for 4 years, and there I worked for a consulting firm. And what I like to tell people I learned there was how to write software properly. So I was using version control, Subversion, right? GitHub didn't exist back then, so we were using Subversion, but I learned about object-oriented programming and SQL databases and all of these things that you really need to write software that can be used by other people. Like when I was in grad school, I was writing code. When I was a consultant, I was writing software that could be used by other people, mostly in the transportation industry. And so the field of data science obviously existed at that time, and it was kind of ramping up, but it wasn't, I wasn't really in it at that point. So maybe Don will have some more. This was back in 2007 to 2010, let's say. So I wasn't really in the field at that time. But after a few years at Princeton Consultants, I moved to Toronto. And that's where I worked at a neuroimaging lab. So I worked at a place called the Mouse Imaging Center, affiliated with the University of Toronto. And what we were trying to do there is understand how genotype affects the phenotype of the brain, and using the mouse brain to understand how the human brain works. And so what I was doing was doing a lot of statistical analysis in R. Some of you might use R. And I was writing pipelining code in Python, because what we would do is scan the brains of the mice, but in order to actually analyze them, they all had to be lined up correctly. So I was doing a ton of statistical analysis, a ton of programming in Python. Physics is very mathematical, but you're not really a statistician, right? Like you're really good at doing complex math, and you understand statistics, but not in the way I think that sort of sets the table to do machine learning and data science. And so when I moved to Charlottesville in 2014, that was really, I felt like I had built up this toolbox sort of unwittingly to land at Elder Research, which is here in Charlottesville. They've been around for almost 30 years. Awesome company, happy to share more if people are interested. And that was at the time where data science, a lot of our clients were like, hey, we have all this data. We don't have an internal data science team. Like, what do we do with it, right? Like, what do we do with this data? Can you help us? And I like to tell this story because I think it's indicative of where the field was at the time. And of course, I'm very excited to hear what Don has to say about this. Is we had a project with SolidWorks. Does any of you know what SolidWorks is? It's a software company. Yeah, I used to design things. Autodesk is one of their competitors. And what they wanted to do was understand their users, segment the user population based on how they were using the software, right? Like they had all of these logs. Every time we'd click something, someone would click something, they would log it all in a database. They're like, can you help us segment these users? And we said, yeah, sure. So they mailed us like an actual hard drive. They physically mailed us a hard drive. This was 10 years ago. And it had all this data. It had, 3 terabytes of data, which today is maybe not that big. And so we started looking at it and interrogating it, and we said, how many commands do you have in the software, right? Like what is going on in the software? Do you have any sense of it? And the business partners we worked with were like, there's maybe like 300, 400, maybe 1,000. And so we look in the database and we find that there are 10 million unique commands, which is a way bigger number than they were expecting. So that was, so we were able to understand what was happening. The software was executing a lot of commands that the users didn't know about. But I think it was a really good introduction to the problem space because you have all of this data and it is always going to surprise you, right? And what we were trying to do was gather information from this data and tell them, like, here's some customer segments, right? Like, Is there 5? Is there 10? Like, what's the right number of customer segments, and what can we learn about them? And so we did that, but there wasn't really a thought to, like, how are we going to operationalize this? Like, how are we going to present it to people to use? How are we going to feed in new customers for which you have no information and try to put them into a user segment, right? Like, we just weren't thinking about that at the time. And what I found over my time at Elder Research is, towards the end of my time there, and working with a number of different customers, what I came to realize is that even though we were really invested in doing a good job and doing right for our customers, there was no way we could understand the business as well as the people who work there, right? Like, you have to be sort of embedded in the business to do the best data science. And at the time, that's when we were starting to see more of our customers, like, standing up internal data science teams, right? And so that was like an evolution I saw in the industry, going from, like, hey, we have this data and we need to learn something about it, to, like, oh, actually, we need an internal team. This is, like, a lot bigger than we thought. And so I had a great experience at Elder Research, but I ended up going to Scoffos, which was an e-commerce startup in Charlottesville. Now, unfortunately, it did not survive the pandemic, but what I learned there is sort of the challenge of building a piece of software that you can sell to these teams, right? Like, we were trying to build a platform for doing machine learning. And there was this sort of evolution, not only like, hey, we have all these internal data science teams in our businesses, but, like, we need software and we need technology to use it. And if you are a really small to mid-sized company, probably you're going to use something from Amazon. You're going to use SageMaker, or maybe you're going to use something from Azure. You're going to use some product from Google, right? Like, you're probably not going to build something yourself. There's sort of an intermediate space where the build versus buy decision is less clear. And then if you are a huge organization, say maybe the size of Capital One, you have your own engineering teams that can sort of build custom stuff as you need. So that was a really interesting experience, and certainly, like, neural networks and tools to use neural networks were were sort of coming to the forefront. So then fast forward today, and fast forward to Capital One, where I've been for about 4.5 years. I would say that my initial time at Capital One, obviously, like, LLMs were not a thing like they are today. We weren't really thinking about that as much as we are today. But I am very, very lucky to be in an organization where we are very forward-thinking in terms of technology, and we don't just think about, hey, how can I build a model that's really, really accurate, or gives me really good recall, or whatever it is, but how do I actually use it, and how do I actually operationalize it? And we've shifted from this mindset of 10 years ago of, like, hey, I have a bunch of data and I need to do something with it, to I need to build a model and I need to think about, like, the engineering first. And I think the best example of this is transaction fraud, right? So you go to the grocery store, you swipe your credit card, you wait a few seconds, you pull it out of the terminal. Many large banks have a fraud model that's predicting the likelihood of whether or not the transaction is fraudulent. In some sense, like, the accuracy of that model, it has to be good enough, but the amount of engineering that has to go behind the scenes to make that run smoothly is huge. Or think about, like, ChatGPT, right? The LLMs itself, right? Like, that is, like, cutting edge, but the fact that we can all go and, like, type stuff in and we get a response relatively quickly, like, that's a phenomenal amount of engineering. So I think we've really evolved as a field, just almost think of, like, this engineering first mindset. So that's sort of how I think about this. And I could say a lot more, but I think I've used up my 10 minutes, and I really want to hear what Don has to say. So
thank you. Yeah.
Awesome.
Your take on data in the real
where do
world.
we start? First off, thanks so much for having me. This is awesome, and thanks for the kind intro. You said a bunch of nice things. I actually feel very much more like an accidental tourist when I think about my career journey, and much like Miriam said, in retrospect, when you think about it, it seems to make sense, but in real time, it was very, it definitely wasn't as intentional as it kind of turned out. So I think my journey actually begins, like, way back when I was 12, when I was actually programming computers in a language called Logo. She didn't mention my graduation date because she's too kind. You're kind to your elders.
I can't.
But I was literally programming a robot turtle, like draw shape, Logo back in the day. I think my computer was like an Atari 2600. Yep. And then I ultimately ended up going to McIntyre. I graduated in 1998. Again, a bit longer in the tooth than some folks. But I do think that having this combination of a bit of a technical background, some hands-on keyboard coding and programming there, alongside and paired with more of a general sort of business background has been really key to my whatever success I've had along the way, and candidly some versatility. Mona touched on it, but I think I feel very much like Forrest Gump, and my journey as Forrest Gump in my career has really spanned a bunch of different areas. I think when I first moved to New York after graduating from McIntyre, I worked for a startup that built startups. It was called Scient. We built all sorts of startups. It was one of the first social networks called 6 Degrees. It was based on 6 degrees of separation. The first like Chase.com and a bunch of other kind of startups. And then I ended up being fortunate enough to be put on a project for MLB.com. So in 1999, Commissioner Bud Selig convinced 30 owners to consolidate their digital rights into a single entity, MLB Advanced Media, and so they needed someone to build it. I was a data engineer on that team and got to take the Elias Sports Stats for baseball fans. It's kind of like the Bible of baseball stats. And so we put together our first stats database, and I was kind of like the data engineer for that. The bubble burst, and they ended up hiring a bunch of folks from our company. And after a couple hops, I ended up being a founding member of the customer analytics team in 2005. So I was at MLB Advanced Media from 2005 to 2018. That was a really interesting journey because, this kind of mirrors like a few different technology waves. I guess the first wave was like Web 1.0 when I first moved to New York in '99, and Pets.com, which failed, all these kind of like famous things. The next wave, which I was fortunate to be at when I was at Major League Baseball, was the wave for video streaming and for mobile. A lot of folks may not realize this, but the iPhone didn't always exist. It was actually launched, and baseball was on the stage. We had an app called At Bat, and we were very fortunate to be there at the very beginning, and really believed in mobile as kind of the first interface that we thought was going to be where everyone ended up engaging with technology, and turns out we were right. I remember a lot of people were skeptical about watching a small 2-inch baseball game on your phone, but it turns out it's pretty popular, and so we ended up building a massive video streaming platform. That ended up getting white labeled and sold to Disney for $3.5 billion at the back end of Disney Plus for folks that use that product as well. And then from there, I ended up going to WeWork, pretty infamous startup. We can talk about that over an adult beverage, but learned a lot. Grateful for the experience, couldn't have learned it anywhere else. And then ultimately ended up doing a complete 180 and going into the insurance field. And what the nice thing about the insurance field is there's incredible scale, $52 billion a year company that I work with now. And so that really gives us a lot of opportunity. All along the way, I would really echo what Miriam has said. What I've learned is that it was very much about thinking about the business problem that you're trying to solve and kind of working backwards and understanding how AI, data science can actually move the needle to affect that outcome. I think there's kind of like a little bit of a somewhat cliche framework, but from an analytics perspective, you have descriptive analytics, accurately conveying what happened in the past, diagnostic, understanding the why, predictive, forecasting the future, and then prescriptive, how do you actually change the future. And in almost all of the places that I've been, I've seen that kind of journey just in different contexts. So at Major League Baseball, it was, there was on-the-field application of these analytics and then also off the field. From an on-the-field perspective, one of the neat things that they innovated at Major League Baseball is they put 2 high-speed cameras and radar in all 30 baseball parks, and they tracked the movement of every object on the field from the ball itself to every single player. And they put all of that into a massive Redshift database, and they gave it to all 30 baseball clubs. The whole ethos of MLB Advanced Media was to try to raise the floor of the league, to give, whether the Kansas City Royals or a small market team or the New York Yankees, you have the same playing field with respect to your digital capabilities. And so this is what they did with data. They democratized all the data of every single player and every single play they did on the field across 2,400 live games. And so what ended up happening was the differentiation of how you leverage that data came down to the data scientists. It came down to the analysts. How do you best use that data to optimize the performance of the players on the field? And they were able to quantify player performance in ways they could never do it before. So defensive stats or offensive stats had been pretty well developed, but defensive stats were not nearly as robust. But now, with this StatCast data set, you could literally understand what was the jump of Mookie Betts in the outfield when the ball comes off the bat. What was his reaction time? Did he take the optimal angle to get to the ball? If you compare his movement to every single play and every single outfielder in all of Major League Baseball in the last 10 years, did he make a play that was exceptional, that was in like the top 0.5% of all plays that are ever made? So that level of quantification became democratized and distributed to all the baseball clubs. So that was one really interesting use case. And again, it started from the problem of how do we maximize player performance and optimize it, and then working backwards to these new tools and methodologies that were never available before. And then on the business side, there were just so many opportunities. So baseball sells about 70 million tickets a year, and those tickets don't sell themselves. And half of those tickets are sold through direct-to-consumer sales, and half of those tickets are sold by ticket salespeople that, call people on the phone and try to sell group and season tickets. And so we applied things like lead scoring, understanding based on individuals that expressed intent in buying tickets, like how do we consolidate that with third-party data, our own first-party data, their engagement with our websites to determine who was most likely to purchase. So there was a kind of a business lens to that as well. And so yeah, those are two just very specific use cases, but just like Miriam described, it all came down to like, what is this outcome we're trying to affect? What's this business problem we're trying to solve? And how might these capabilities, unlock new potentials? And in all the other places I'd ever been, whether it was at WeWork, where they were trying to best understand similar like acquisition kind of metrics and how they could influence it, or whether it's here at New York Life, where we're trying to understand how we could best meet our clients' financial plans and meet their financial goals. There's this really consistent, what I like to say is like the problems in data aren't the same, but they rhyme. Yeah. There is a very consistent theme and analogy that's allowed, and I think what's so amazing for folks like you guys that are at the beginning of your journey, data science is so horizontally applicable. I don't think there's not a lot of people on their bingo card that have Major League Baseball, WeWork, and life insurance. Yeah. I'd love to meet them I'd like to meet the other person, but that was all possible because of the amazing versatility of the skills that you guys are all learning today, everyone in this room and beyond. And I think you noted it. You mentioned leading with empathy and understanding the business context. I think those kind of soft skills I think are just as important in understanding the business context as the hard skills that you learn in Python and all these various libraries and fine tuning of LLMs and all that good stuff. So.
Thank you. Wow. So you see why we brought these two together. I have a pressing question myself. So one of the things that we're trying to do here at the School of Data Science is to shape the field of data science, both in terms of the field, quote unquote, out there, the business, but also the scholarly academic field, and we're really committed to doing that in an interdisciplinary, cross-disciplinary way. So what's your hot take on a definition of data science, personally, today, from Miriam, from your point of view? If you had to describe it in one sentence, what is data science?
Oh, boy. I think I would say that you are trying to take data and extract something meaningful from it that you can't do without the data, right? And there's many different techniques, and I actually love what Dawn was saying about like the problems rhyming, right? Because there's so much, everything is like extremely horizontal, and techniques for one problem are actually very similar to techniques you can use to solve a totally different problem. But I would say, if I had to say what is data science, it's taking data and you do something to it, and you learn something that you can't find out any other way.
So very specific techniques for knowledge production, essentially, or insight. Dawn?
She's a PhD and I'm not, so I'll roll with what she said. I mean, she's bending spoons. I have like sticks and rocks over here. So yeah, we'll roll with that. No.
All right, so knowledge production. When you think back 10, 15 years, all the things you've done, both of you said something along the lines of, I didn't plan this. Data science happened to me. Surely not all of this went smoothly. What were sort of certain dynamics that you observed, certain opportunities that you saw that you couldn't pursue, or the organizations that you were embedded in couldn't pursue? What were challenges as you effectively built the field of data science and industry? Maybe we'll start with Dawn, because you didn't answer my question.
Yeah, I know. I totally dodged it. I would say the biggest thing that I reflect on is that I would encourage everyone in this room to be a voracious, lifelong learner. doesn't need to be said that everything that I learned when I left McIntyre in '98, although it was substantial and laid a great foundation, I've learned quite a bit since then. I did not have a strong science background. I recall very vividly when I had to start getting into machine learning, start building recommenders and leading teams that build recommenders, needing to have some domain expertise such that I could lead these teams. It was hard. Like, I really had to grind at it. I had to try to figure out the right way that I could learn and absorb this material. And the same goes true as we've reached every new wave of technology. Of course, now LLMs. And so I would say, like, be a voracious, lifelong learner. That's something that I've had to embrace, and just like the grit that's involved with it. The second thing I would say is you can't underestimate the importance of the business context and the context in the domain within which you're working. In the absence of that, I think observations and certain insights will not be as grounded and as effective. And the outcomes, and I think I oftentimes anchor so much on this notion of impact. I think my teams and what we always hope to achieve is some notion of impact, some sort of like positive business outcome, leave it better than we found it. And that impact is really going to be most effective when you understand the context within which you're working, whether it's trying to sell more baseball tickets or sell more life insurance or whatever that might be.
All right, so context.
Context and voracious
learning.
Lifelong learning.
Lifelong learning.
It's a mouthful, but yeah.
Yeah. I strongly agree with the lifelong learning piece, and also recognizing that no one person is going to know everything. Like, in order to deliver that impact, you need people who are statisticians. You need people who are really good at just like wrangling data and saying, like, what do these 10 million commands mean when our customer expects like maybe 1,000 at most, right? Like, you need people who are really good at engineering resilient pipelines, right? Like, I have, one of my colleagues I work closely with is an engineer. Like, I've learned so much about delivery from him. And he's always like, the thing I hate about physicists is they want to like design a whole system from scratch. And like, he's like, can we just get like one Jupyter notebook working? Like, but you need both of those things, right? Like, you need both of those things. And so I want to sort of strongly +1 the lifelong learning and being humble and knowing that like you don't know everything. I think the other thing, like, Mona, you had asked about when things don't go right. And I would say, for me, places when it hasn't gone right has been two things. One is not prioritizing like the business context or impact, which requires a lot of listening. And like, it doesn't always matter if you've looked at the data and you are like certain your answer is right. Like, it doesn't matter. You have to listen to what your partners and stakeholders are telling you. And the other thing, I'm thinking of a situation a couple of years ago where I was trying to, so as Mona said, I build like tooling for the enterprise. So Python libraries, I don't know if any of you know Kubeflow, we can talk about that, Kubeflow pipeline components, like templates, so that all the data scientists at Capital One in the lines of business can build these models and deliver this value more quickly. And we had noticed, so in an organization as big as Capital One, sometimes things are duplicated, right? Like, one group might be doing the same thing another group is doing, not because they're trying to like gather scope or like be possessive, but just because they don't actually know. And so we had found some duplication in two of these libraries, and I was trying to converge them, right? And say, like, let's remove this duplication and converge them. And one of the libraries, there was a lot of problems with it. Like, and the reason I say that is because we had a document from customers saying, like, hey, this doesn't meet our needs, right? Like, here's some challenges. And instead of sort of, acknowledging that this wasn't a library that I owned, I was trying too hard to make everybody like feel good about the challenge as opposed to actually solving the challenge. And so sometimes leading with empathy doesn't mean making everybody feel good. Sometimes it means delivering hard news in a way that is kind and candid. And it's really, really difficult. And Don, I don't know if you've had this, but the further I get in leadership, the more I have to have those conversations.
Yep.
So it's a little bit, to Don's point also about the softer skills, like, that is also something I've had to learn. And I remember someone, more senior to me at Capital One, I was having a conversation with them, and they said, like, what would you do if you didn't have to worry about hurting anybody's feelings? And it was not the decision that I was actually making. So that was like a learning experience for me.
Makes a ton of sense.
Yeah.
Just to build on that, I think you made a comment earlier on about like teamwork and the multidisciplinary aspect of what we do. And I think this notion of like data science as a team sport is something that comes up a lot, and I think it's totally true. With respect to the second piece, I couldn't agree more, and I meant to mention it before. I think the ability to actually communicate and convey in a concise and a digestible manner what you do and why it matters is actually, I think, only gets more and more important as time goes on. And it's always interesting because, at least as my career has progressed, I have to like do that at very different altitudes. So whether it's like a board of directors, or it's like my team that's delivering, or a staff data scientist, or whatever that is, I think the ability to actually communicate concisely whatever you need to convey, whether it's the business context for certain engineers, or whether it's why this stuff matters that we're building to a board of directors, I think that's a really valuable skill that you can never, to continue to try to master if you can.
Yeah, strong +1. The communication is essential, and knowing, like, if you're talking to the board of directors, it's a very different conversation than if you're talking to the data scientists, and you have to do both. And how you convey information. Like sometimes you literally get like 2 sentences to convey the importance of something.
I mean, I remember very vividly being at Major League Baseball, and we were trying to discuss our churn model. So MLB.TV is a video streaming product for Major League Baseball. There's around 2 million subscribers. There's monthly and yearly products. And we were trying to predict monthly churn, and we were able to get it down to like close to the day, because there's like a monthly billing day, and we all cancel right before we're about to get billed, right? But we could also base it on like the usage. We could understand when people started degrading usage, and most explicitly, like multi-platform usage started to degrade. And I remember trying to explain this to the CEO, and the CEO was a former CFO, and he thought in a far more linear way and not in a multivariate way. And he was like, well, it's all about usage, and it should be this, and then this, and it was a very like linear sort of rationale that he had in his own head. And we tried to mention that this was a multivariate problem that we had. We threw all these things in. I felt like literally the visual that I had was like I was on a boat and like waves were crashing on me. So that was like a very hard lesson. Like, okay, I need to learn how to like articulate this in the appropriate way such that the business folks can understand exactly why it matters and how it works.
So then it seems that data science really is about producing new insight, producing knowledge, but then also communicating that new knowledge in a very specific and sort of embedded way, right? Both of you said, well, you got to be close to the business, the problem, the field that you're operating in, the questions. As a researcher, we would say, and I say this to my students who probably think I'm a broken record, stay close to your research question, right? Try to answer your research question. What has helped you in learning to communicate with data or through data? What is maybe an experience, a situation? You just spoke about the ways, but maybe a positive one, where you're like, okay, now I get it, and now I know how to do storytelling through data to get the insight across, even if that's insight that some people don't want to hear.
I mean, you said the key word is storytelling. I think there's a woman named Nancy Duarte who has a TED Talk about TED Talks, and she has an amazing program.
Very meta.
Yeah, very meta. Has an amazing program about how to storytell, whether like visually through slides or narratively. And I and my leadership team go through that because I do think this aspect of storytelling is so critically important, and developing that. I'm trying to think of a specific example. I would say like on a day-to-day basis, I think there's more relatable examples in the field of baseball than perhaps life insurance. So oftentimes with my life insurance partners today, when we're talking about things like, well, how do we sell more life insurance, or how do we cross-sell these tangential products, I oftentimes speak to the work that we did at baseball just because it's just more relatable and understandable. So perhaps just the storytelling with analogies that you think that folks can more easily connect to is one thing that's worked for me.
Mm-hmm. Okay, literally inside baseball.
Inside baseball.
I would say for me, it is, you want to come in with sort of a really concise and well thought out story, but you also need to be able to listen to your audience and like allow them to ask questions. And when they want to talk about something that's not what you want to talk about, you have to like pivot a little bit, right? Because that gives you insight into how they're thinking about the problem. And I can give a very recent example. Earlier this week, I was presenting about some work to someone on our executive committee. And he asked a question, and it was very clear to me that he did not, I'm on slide 3, it was very clear to me that he did not really care that much about what I was going to talk about on slide 4, even though I thought it was really interesting, right? Because it involved like open source contributions as like one thing that this project was helping to do. And so I was like, okay, I'm going to skip slide 4, and I'm going to go to slide 5, and we're going to talk about the thing that you want to talk about, right? So I think part of storytelling through data, of course, is knowing the data and keeping your story really crisp, but also listening to your audience and making sure that you are addressing what they want to hear about. And I will say this is something I'm still learning. It's something I used to be terrible at, and it is something that I'm now better at, but it's come through a lot of process. Like sometimes I joke with people, like my job is I'm a professional talker. Like I spend a lot of time on like Zoom calls and like gathering and conveying information, but I think that that's also, the storytelling, I think that's a part of it.
I want to shift gears just a little bit. We are learning about situations, data science products, algorithms that are harmful to people. We have plenty of evidence of said instances, some of which include scoring, risk scoring, sort of techniques that both of you are intimately familiar with. We have had efforts to develop regulation around that, not just sort of on the, of course, on the policy level, but also sort of, I would say, genuine engagement of industry in those conversations, and where data science teams are quite active because they know the data and they know sort of how these problems can show up in data science. And I wonder if you can speak a little bit about that, how over the course of your career, not just in your current role, you've maybe encountered these kinds of problems, or the early days of algorithmic harms, how you started to think about that, and maybe how this features in your work today. Maybe we'll stay with you, Miriam.
Okay. Well, I think the first thing is I don't know if it was like my scientific training or if it's something else, but I'm sort of like a deeply skeptical person. So I think with any model, and like if you build a model and immediately your results are amazing, my first thought is like, what is wrong? Like, where is the error, right? Just like, so I think you have to be deeply skeptical. I will say one of the things, this is more present day than historical, but we're actually very lucky at Capital One and that we have a model risk office function in our company. And because we're a highly regulated industry, which I'm a consumer of financial products, like you all are likely consumers of financial products, right? Like I deeply appreciate how seriously Capital One takes data privacy. But one of the things as it comes to, results of algorithms that could be harmful, we are not allowed to put any model in front of any customer until it has been thoroughly vetted by our model risk office. And what that means is, so let's say I'm building this transaction fraud model that I spoke about earlier. I have to write what's called a white paper to give to my model risk officer. These white papers are often longer than my PhD thesis. And I have to provide links to my code. I have to say, here's why I chose this random forest versus, this other one, or whatever it is. Here's the features I use, right? So I have to be very specific, and I also have to explain how I know that my model is not doing any harm, that I have really pressure tested it under a number of different economic scenarios. And so the model risk office reviews this with a fine-tooth comb, and they will reject models from going to production if they think they're going to be harmful. So I appreciate that level of oversight, and I think to me the question is, how do we as data scientists, or we the people building the models, can inject some of this oversight into our own work so that for us, when we hand things off to the model risk office, it's a much more seamless transition because we have thought through that at the beginning. And the flip side of that is then the models can go to market more quickly, right, if you can accelerate that process. So. Thank you.
Yeah, so this is an issue.
Don't just say +1.
No. Ditto. No, this is something that's near and dear to my heart. This is something that an area that I wasn't as actively involved with in baseball, but certainly as I've gotten into a more highly regulated area, then it's something that I deal with every day. So one interesting thing about life insurance is we obviously have underwriting. We have data, and then we ultimately do a risk assessment. And much of those risk assessments, most of them now, are driven by machine learning. And we have, one of the challenges that we have, there's no like national regulation. We actually have to deal with a patchwork of 50 different states. Certainly there are certain states that have more rigorous standards, and thus we end up conforming mostly to them. Colorado is the most prominent one in our industry. And we actually have, the burden of proof is on us. We have to prove that our algorithms don't have a disparate impact on protected classes, whether it's race or gender and things of that nature. And so we actually very robustly work with our trade organization to come up with the appropriate guardrails. We end up not just evaluating the scores or the algorithmic output, but we also, the data that is input that we even consider being put into our model. Sadly, as we all know, there is bias within society, and sometimes that actually ends up manifesting in the data. So as an example, driving records oftentimes, like people don't always get pulled over in the same sort of, there's not necessarily equality in general in that context, and so we explicitly don't use DMV and those sorts of like traffic stop sorts of data, but we may use other data. So I think we look at it from a couple different lenses. The data that's actually going in, there's some level of bias and bias review. We also have like the algorithms themselves and the scores that come out. And just like Miriam said, we have a very robust like risk group. We have an audit group. We have a privacy group, and we have our the AI and data science folks. And we all work together to come up with like the processes to ensure we have the appropriate guardrails. And then the same thing, there's other kind of very sensitive areas such as employment law for which we have to do a lot of similar things. So.
Thank you. It sounds like the field of, say, responsible machine learning or AI is a growing field. Is that fair to say?
Yeah.
Absolutely.
I think that's good news because we have a bunch of students who are really interested in that.
Yeah.
Speaking of the future, the field of data science is growing. So are we. It becomes more relevant in all the ways, not just the knowledge production, but what role does data science actually play in society kind of way. Where do you see the future of data science go? You've been with it for a good long while. You have some data in your head. You can make some predictions. What's your prediction about the future of data science, Miriam?
Oh, I have to go first again? Okay. So I think we're going to be surprised. Also, when you talk about the data in my head, I like to joke about like my neural network model, which nobody finds funny. I think you're talking about responsible AI, which immediately now I think about like LLMs and guardrails and hallucinations, and we're at the point where we're generating all this data that's not, until, with some exceptions, like until the sort of like step change with LLMs, like most data, like as Don said, like humans decide what data to collect and they decide how to use it, and there's inherent bias, and so now we're creating all of this data that is, some of it, which is trash, like created by these LLMs, and so I think that we're going to be surprised. I'm not sure where we're at in the Gartner hype cycle, like if we're at like the top of the hype curve or if we're coming down, I'm not sure yet. But I also think that I have this deep belief, which may be completely wrong, but I think like as much as there's like a lot of exciting learnings from these new technologies and the field is evolving so quickly, like fundamental best practices, like getting back to what I said at the beginning, am I calculating what I think I'm calculating, and do I know how to validate that? Like that's not going anywhere, right? Or like best practices in terms of like transparency and software engineering, that's not going anywhere. And so I think it's gonna be really interesting to see the balance of like, as we use this new technology, like the importance of these sort of fundamentals. But I actually, I don't spend a ton of time like thinking about where we're gonna go in the future. I think, like you said, you just kind of like wander into this field, and I couldn't have predict any of, where I've been. So I guess that's my hypothesis, but I am prepared to be surprised.
I guess I think about a couple different vectors. I think on one vector, I'm pretty optimistic. I'm just a generally optimistic person, and maybe it's kind of like the venture in me like mindset. Versus like the PE thing, but anyways, I think about like the upside a lot. I think certainly like there's going to be a lot of disruption, but I get super optimistic when I think about my kids who are 10 and 12, growing up in like an AI native sort of environment. Like we already talked about how, again, I'm long in the tooth, so like I remember like meeting up with friends at the fountain at the mall. There was no cell phones to text and everything, and then I saw the iPhone launch and all this other stuff. And when I see my son like say like, hey, I want to like make a video game, and he like starts to like talk to ChatGPT about different ideas, and then he starts talking about like these hamsters and these different forests, and there's a fire forest and a sea thing, and then they come up with a name, Hamster Havoc, and then he creates a logo for it, and then he like says, yeah, well, what's a platform that I can actually like build this game? I was like, oh, there's this thing called Unity, and so he like starts doing like Unity code and going back and forth, and like I just think like the potential, the human potential that is going to be unlocked by these tools that give you superpowers are going to be incredible and allow folks to just do things that are amazing and, you know, discover new drugs and all this other. I don't think I'm a naive optimist. I understand that there's also the flip side of that and the cautionary tales that we need to be mindful of. Of course, we have to have the right guardrails. But I am in general like quite optimistic about everyone in this room, all the you know, the possibilities you all have. And I do see, you know, we talked about, you know, data being a team sport. It's going to be, I feel like a lot of these capabilities will be far more democratized. So it's a bit of a cliche. People talk about how like the programming language of the future is going to be English, right? Because you can literally talk to an LLM in Cursor or whatever, and they can create like Python code for you or generate a library for you. And now with agents, you can even like launch things and launch code and deploy it and everything. And like we're just so early in this exponential curve, and as humans, it's hard to know when you're in an exponential curve, but it really is quite exponential. So yeah, I'm just like super optimistic, and I feel so excited for everyone in this room. I feel incredibly grateful to be on this stage and having had the journey that I've had, and even the time before me. Even though I'm long in the tooth, I'm still going to work for a while. Got to put 2 kids through college. UVA is not cheap from out of state. But yeah, so I'm like super optimistic. I think it's going to be great.
Which brings us kind of full circle to lifelong learning and learning, right, in a way. So my last question for you before we have about 15 minutes for audience questions is, if you were in our students' shoes today, here in the School of Data Science, what would you tell them? Sort of your today's self to your data science student self today, what would be something you definitely would want them or yourself to know? A nugget of wisdom for all of us. Miriam.
So I was thinking about this question earlier this morning, and I think it is, I think the best phrase, and I actually mean this in a positive way, it might come out a little negative. Unlike Don, I'm not really an optimist. So we are lucky in town to have an amazing data scientist named May Casterline. I don't know if any of you know her. She works for NVIDIA. And she's a phenomenal speaker. If you ever get the chance to hear her at like a meetup or something, like I recommend you go. She works for NVIDIA, and she said, she was giving a talk one time, and she said something like, our customers, she's a solutions architect, will come and be like, here's my trash bag of data, make AI with it. And it's literally always a trash bag of data, right? Like the data, so messy all the time, and there's so many tools to learn to extract it or to extract value from it. And I think that like, you're not, like I remember like when I was in school and sort of feeling like everyone around me was like so much smarter and had it all figured out, and then having gone through all the experiences I've had, as I said, like no one knows everything, but like you can deliver value, like you have value with what you know and what you're doing and the perspective that you bring. And like even working in some of these open source packages, I was chatting with an engineer the other day, and he was like, I'm shocked that like, Kubeflow pipelines didn't have this sub-pipelining capability. Like that was really surprising to me. And it's this huge community of developers that are using it. And I came in and was like, hey, like actually this would be valuable, right? So like what you have to bring to the table, right? Like you will make an impact, and it's not that everybody around you is like so smart and has it all figured out, and there's like no mythical perfect data set, right? Like it's always a trash bag of data, and you just kind of have to like incrementally learn and just be really like indefatigable about like solving problems, right? Like when you're writing software and you get an error, right? And so you go up the stack trace and then you fix it, and then you run it again and you get the next error, and you keep going over and over till you solve the problem. It's just not being afraid to like keep going and solve the problem, because this is such an interesting field. Like there's so many good, like interesting problems that we get to think about. And like Don, I am super grateful for this career and this journey. So I think that would be, I wish I had known that my younger self when I was in grad school and thought everybody knew like 400 times more than I did. So
That's great.
I love that you started with the trash bag of data. Because the other thing, like one of the cliches is like garbage in, garbage out,
Yes.
and I couldn't agree more that some of the old school, the things that were like so important even way back when for being a data practitioner are just as important now. And now I have like business partners talking about data quality, which is a weird thing.
Yeah.
So, but I'll take it. The thing that I would convey to this group is, I mean, gosh, you're so early in your journey. I mean, just try a bunch of stuff.
Yep.
See what actually like gets you jazzed up and like motivated to just really hustle hard and grind out, because it's going to be a long and fun career. You're going to meander, and it's going to be an accidental, in some ways, journey for a lot of you. Many of you will maybe have a straight line, and you know exactly what you want to do, and you're going to get there. But for many folks, it will be kind of like maybe not a straight line from A to B to C type of thing. And so I would just embrace that, embrace kind of change and agility, and don't be scared as things come that might turn your world upside down a little bit. I think some people get really threatened, and I have some data scientists even on my own team that get like worried about a lot of these advances. They worry about their skills being diminished, and you hear that oftentimes. I think the cliche is like AI is not going to take your job, but someone using AI will. But I think that generally speaks to this notion of just embrace the changes that are there, treat it as a growth opportunity, and you'll be totally fine.
Yeah.
And with that, it is over to our wonderful audience for please ask questions, not comments, if I may. Yes, over here. We have mics. Hang on. Because we've got folks online. Yes.
So, there's a...
Hang on, is it on?
He's turning it on, I think. Yeah. I have faith.
Well, I can speak loud anyways. So there's a lot of companies using generative AI, and especially LLMs, into their products, even though this is still like early on. I would say, 10 more years of benefits for LLMs before they get to like a truly, truly amazing place. But going forward, with all the hallucinations and stuff and jailbreaking that's possible with LLMs, like, what are the next steps that we need to focus on to prevent these sort of things, so that these LLMs can become like truly useful, maybe 99.99% accurate or whatever, and like, just what are the next steps for that? Is it just cleaner data, more data? Is there an advancement that we have not yet, found? Yeah.
For whom is the question? You can choose one.
It doesn't matter, yeah.
Yeah.
Team effort either.
Yeah,
I
you
can-
can go first,
I'll
because I keep
start.
having to go first to answer.
Yeah, you've been going first all the time. You can say ditto this time.
Yeah.
No, I would say, look, there's a whole slew of techniques. Like, it's funny because, of course, enterprises care a lot about accuracy and making sure like the right answer comes out, particularly in contexts like knowledge management, as an example. So there's all sorts of techniques that are being used today. I think hallucinations are certainly something that we understand. It's a probabilistic and not a deterministic technology, right? So what do you do in order to kind of reduce that? There are techniques like RAG, there's techniques like guardrails, there's obviously like eval frameworks by which you continually and iteratively use subject matter experts in order to find the results. There's like things you can do in the UI. So although it's an imperfect technology with respect to getting an explicit answer all the time, there are ways to actually design those. And we talk all the time like AWS, we talk all the time to all these other vendors that are trying to solve that same problem. I think more than anything, as of, who knows when they'll solve it and crack the code, I think the accuracy of these foundation models improves with every successive iteration. Now they're like optimizing at the inference stage, right, with like O1 and these reasoning models where you're starting to see things start to reduce. That being said, I think in most use cases, we do have like a human in the loop that tends to make final decisions, at least in our use cases. I think that's one of the guardrails that we have in place. So whether it's like customer service or even, coding and software engineering is another very common one that we're seeing traction in. You still do have like an engineer or someone at the end of the, within that process that's still there. I mean, at what state will they be that we feel comfortable enough? I think one of the times we oftentimes forget is that humans aren't perfect either. So in the context of customer service, as an example, you might have an LLM that's trained on a knowledge base for a customer service rep that the baseline for accuracy of those responses might be, of the human response might be actually what you're trying to aspire to versus like 100% accuracy. Perhaps there's an incremental improvement on what the human had done before. So I think it's less about 100% accuracy and perhaps more about understanding the nature of the technology and having appropriate guardrails. Does that make sense?
Yeah. I would also add, I could just say +1, but I'll also add a little bit. So, I spoke about our model risk office, right, and how, we're highly regulated. And we've had this, like, historically for many years for what I like to call, like, classic ML models. So, of course, that also applies for LLMs, right? And I think, beyond anything, I feel this globally, not specific to Capital One. Like, if there are companies building tools, agents, whatever, based on these LLMs, like, we need to be responsible about what we're putting out there, right? Because, like, any old human can go to ChatGPT and type some stuff in and, garbage in, garbage out. Yeah. But I think if you're building, for companies who are building products based on this stuff that's going to go and potentially really impact consumers, I think, we spoke about responsible AI. I think it is incumbent upon us to be responsible and thoughtful and put many of those guardrails in place. Yeah.
Absolutely.
Thank you. We have time for more questions. Over here, yeah.
My question is, since you both come from kind of non-traditional backgrounds, like, what are some tips or some ways that you were able to build that kind of data science technical expertise, whether it be on your own or just collaborating with colleagues to learn more about coding and things like that?
Well, I mean, you actually had a harder science background, so I feel like maybe it was easier for you in some cases.
Yeah, I will say, like, because even though, like, I didn't really have a training in, like, a data science per se, I am very comfortable with complex mathematics, and I wrote a lot of code for my PhD. So for me, it was just sort of like shifting how I, applied that knowledge or how I thought about things. But I think that's also a lesson, because anyone who's in, like, sort of a technical field, like, I think whatever it is, like, the jump is probably not as big. And I will also say, even if you're in a non-technical field, if you are so interested in this stuff and you're learning from colleagues or you're learning on your own, you can become an amazing data scientist. One of the best engineers I ever worked with has a degree in, like, I don't know, Japanese literature or something. Like, he just something so not technical at all, but he was just such a creative, like, brilliant thinker and taught himself. And so I would hire him on my team any day of the week because of, like, he took it upon himself to learn and was really passionate about it. So I know that's, like, not a super helpful answer, but yeah, okay, good. But Don, I'd love to hear from you.
Yeah, no, I would just, what I would encourage is just, like, learn how you best learn. So some people learn best by taking an O'Reilly book and pouring through it and then actually, like, creating code. Some people best learn by using ChatGPT. Some people best learn by watching a YouTube video. But I would encourage that, and then really embrace the opportunity to take on projects and have, like, hands-on experience in a lot of different domains. I recall when we would hire interns at Major League Baseball, a lot of these folks had taken these publicly available data sets and done amazing things with them. I think, you're only limited by your own motivation. Yeah. I feel like this is kind of a golden age of being able to learn and content and insight. There's so many incredibly smart people for which you can get data, information from Substack, or there's stuff on YouTube. I really do feel like we're in this golden age. So it's more about how you best learn and just having the motivation to go for it. Yeah.
One more question. You have one over there? Yeah.
Hi. Can you guys hear me? Okay. So I have a couple of questions about LLMs. And LLMs usually, they use data from the internet, large amounts of data from the internet. But sometimes data on the internet can be misinformed. Like, say, Wikipedia sometimes is not as accurate. So as LLMs are continually used, how do we prevent more misinformation from happening?
Sorry, can you repeat the last bit? How do we prevent?
More misinformation from happening.
Preventing misinformation in the age of LLMs.
I mean, I think you can go. I can. I think OpenAI and many of these foundation model developers have been pretty open about the techniques they had to use in order to try to prevent exactly what you described. And with each successive GPT release, whether it's like 1 to 2 to 2 to 3 to 5, and et cetera, I think one of the techniques they've talked about is not just training on the entire corpus of the internet, but also using reinforcement learning from human feedback in order of experts, essentially, in order to kind of validate many of these answers. In all candor, it's a lot of Mechanical Turk is a service from Amazon Web Service, which is literally about, at scale, being able to leverage human labor, essentially like humans and human experts across the globe. And then similarly, Scale.ai has a whole slew of experts. So the long way of saying, I think what to date, a lot of the techniques have been things like reinforcement learning from human feedback. I think as things have evolved, and I'm sure you're probably more well-versed in this than I am, but we actually have like LLMs that are actually, in some sense, like talking to each other and validating output. So there's all sorts of like different ways of scaling and validating the output.
Yeah, I think the only thing I'd add is like humans also put a lot of garbage on the internet, so I think it's like so but I think it's a great question. I think
it is.
Yeah.
Well, on that note, it sounds like we all have lots of lifelong learning to do. Please join me in thanking Don Vu, Miriam, Friedel for joining us today. And we have lots of more programming, so stick around and have some wonderful conversations. Thank you.
Thanks.
Thank you.
Thank you, guys. 15-minute break. There's some snacks and beverages. We have Professor Natalie Kupperman in here with a great session on data communications and sports, which is going to be awesome. And then sessions up on the second floor and the third floor. So just head to your next session for 2:30 start, and then we'll regroup back here.
A lot of fun. Yeah.
After that.
I'm gonna be optimistic.